Hi everybody, welcome to another video in discrete math, section 6.3, permutations and combination. So first, permutation. Permutation, a set of distinct objects, so the objects are not the same, is an order arrangement. So the most important in here in this section is in permutation, it has order. So it's an order arrangement of this object. An order arrangement of R element of a set is called an R permutation. Right. And so there are two ways to compute this. One way is if n positive integers R is the integers also the integers less than or equal to n, the R permutation is given by this formula P of nr and equal to n times n minus 1 times n minus 2. We talk about that. Or we can use this formula n factorial over n minus r factorial. Right. Look at this example. How many ways are there to select the first prize winner, the second prize winner, and the third prize winner? So there are 3 winning spots. And there are 100 people. So the way to choose is, actually we just choose one out of 100 different ways to choose the first one. After you choose the first one, there are only 99 people left to choose for the second prize. And after that, there's only 98 left to select for the third prize winner. So you have 100 times 99 times 98. So we have that. Right. So that is if we use this formula of counting. Now if we use the formula, by the way, in other books you might see that. So in that case we have n over n minus r factorial. So in our case, P of 190, select 3. So that will be 100. 100 minus 3. So that is 100 factorial over 97 factorial. Right. And we talked about that earlier. So that equal to 199. I hate when run out of space. Right. I continue here. 100, 99, 98, and then 97 factorial. 97 factorial over 97 factorial. Cross that out. We have 199 times 98. Exactly like what we have here, right? So whether we use the product rule or we just do that, either way. Right. On the calculator, we can say 100 math, then go to probability, option number 2, permutation, and then and we have to choose 3 out of 100. Right, that. Right, next, how many permutation of letter A, B, C, D, E, F, G, H contain the string A, B, C? Right, so we have to have A, B, C in that order, right? So that means we have to group A, B, C together as one unit, and then 1. So that A, B, C is 1 unit, and then D, E, F, G, and then H. So 1, 2, 3, 4, 5, 6. So that's 6. And if we scramble, we have 6 out of 6. Of course, that we use the formula. There are 6 different unit scramble, different arrangement. So you have 6 factorial over 0 factorial. 6 factorial is 720. Right. That's one way to do that. Another way to do that is there are 6 spots. We have 6 choice for the first one, 5 for the second, 4, 3, 2, and 1. Multiply all of this, give us 720 different ways of selecting different permutation or different order arrangement. The key here is order arrangement. Right, next, you and 15 of your friends have decided to form a business. The group needs to choose 3 officers, a CEO, operating manager, and a treasurer. So there's 3 spots. There's 16 total, 15 plus 1, so that's 16. So you can choose one of those 16 to be a CEO. 15 people left to choose for a manager. After that, there are 14 left for the treasurer. So multiply all of that. 16 times 14 times, I forgot 15. So 3360. Of course, you can also use the permutation of 3 out of 16. 16 math. Right. Of course, you can use the factorial as well. But either way, we should have the same thing. Right. Next, how many different ways can a pledge class with 20 members choose a president, vice president, and a Greek council? Once again, we select 3 out of 20 people. Right. And here order does matter. So in a permutation, it is an order arrangement, so we can just scramble the order. And there are 3 out of 20. So we just do that. That's 6840. Or if we have 3 slots, there are 20 possible ways to choose the first position, the president, and then 19 to be vice president, and then 18 left to be chosen to be the Greek council representative. So 20 times 19 times 18. Of course, we should get the same thing. There are 2 ways to do that. Either using the permutation formula or to use the product rule. Right, so that is permutation. The key word here is it is an order arrangement. So in the arrangement, the order does matter. If order does not matter, we have what we call the combination. Right, and combination of element is an unorder. Of course, that's the key word here. Unordered selection of all elements from the set. And the way we write that is CNR, NR like this, or could be NCR like in the calculator here used. And the formula for that is n factorial over n minus r factorial times r factorial. And the one way important thing here is that we cannot use the slot for this. The slot, because that have all order. So by listing the slot, that has an order already. So we cannot use that. What we have, we can use. We cannot use slot. We just have to use. We say order doesn't matter. Order does not matter. Then it have to be combination, and we just go with that. Don't try to put into slot, because if you put in slot, it has order already. So we cannot do that. Right. How many poker hands? That 5 cards out of 52. Right? So if you select cards out of the deck of 52, the poker hand, when you actually play poker, the order of the cards actually doesn't matter. At the end, what happened, what you have for the 5 cards are important. Right? Doesn't matter which order you get what card. So in that case, the key word here is order does not matter. So order does not matter. You can just choose 5 out of 52. So that is the combination of 52. Combination of 5 out of 52. So I'm say 52. Big 5 out of 52. So I have that much. So that 2,598,960 different hands of pokers. Right. Next, check how many ways to select 47 cards out of 52. By the way, this should be the same, right? You have 52 cards. You select 5, you have 47 left. Or the 47 left, there are 5. Either way, they're the same thing. So they should be the same combination. But if we're not sure, we will calculate that. See what happened. So we will have 52 to choose from. And a combination of 47. And we have that much. So that 2,598,960 different hands. Of course, you can choose 5 or to choose 52 or 42. I'm sorry. Either to choose 5 or choose 47. If you choose 5, you have 47 left. If you choose 47, you have 5 left. Either way, the same number of different possible combination. Right. Next, how many ways of selecting a committee of 5 from a class of 30 students? So the class of 30 students, there are 5. This is committee. Unlike previously, when we have the president and vice president, the roles are different. In here, there's only committee. So committee, we say roles are the same. Meaning that order does not matter. And here we select 5 out of 30. So just do that. Have 42, 5, and 6. Different ways, different combination. Right, next. How many ways I select 5 people from a 10-member tennis team, so a team of 10, to make a trip to match to a match at another school. So we select 5 out of 10. Right. So this say just select 5. Doesn't matter. We have to choose in any particular order. So order does not matter. So we choose 5 out of 10. That's 252. Right, like I said, usually this type of problem for the combination, don't try to fit into slot. Just go with it. Just say we choose how many out of how many, where order does not matter. Then just use combination. I'm not even use, actually, just use that for once. Combination of 10. Big 5 out of 10. So it is 10 factorial over 5 factorial times 10 minus 5 factorial. So 10 over 5 factorial times 5 factorial. 10 factorial is 10, 9, 8, 7, 6, 5 over 5 factorial and 5 factorial. Cancel out one of them. And then we have 10, 9, 8, 7, and 6. 5 factorial is 5, 4, 3, 2, and 1. 3 and 2 cancel with 6. The 5 cancel with that, give us 2. And 4 cancel with that, 1. leave 2 and 2 and 8 to 4. So 9 times 4 times 7. Right, so just like that. Of course you can do by hand, but if you don't have a calculator, go with this formula. If you do, use a combination. By the way, any scientific calculator also have that button. Look for the NCR. Look for the NCR button on the scientific calculator. You should have that too. For example, I have this one, and NCR is here. Yeah. Or actually, that rather. I'll use this one. The button is here, NCR. So you can say 5. I'm sorry, 10. Sorry. Okay, this button. Select 5 out of 10. Okay. Yeah, look for that NCR button. Any scientific calculator should have that option. Right, so like that. Next one is a little more difficult. You have 4-person crew to the International Space Station to be chosen from 10 Americans and 12 Russians. How many different crews are possible if there must be at least 2 Americans? Right, so there are a lot of things here. So if we want 2 Americans, at least 2 Americans and 4 people crew, 4-person crew, so they have to have 2 Americans and 2 Russians, or 3 Americans, 1 Russian, or all American. Those are the different cases. Of course, we find how many we have for each case, and then we add all of them up. Alright, for American, we can have choose. Sorry. We can choose any of 2 of 10 American, and then we can choose any 2 of the Russian. So we do that. 10 math probability combination of 2, and then 12 math of 2. Yep. 2070. If you want to 3 American, and then 1 Russian. So actually, if you have this calculator, just highlight it, hit enter, and all now go back and choose 1 Russian out of 12 and 3 American out of 10. That 1440, and all 4 American. There's only, so just 10 C4. Right, so then 10 combination of 4 to 10, and you add all of them up. Right, so 4620. So in this case we have the addition rule as well. We have 3 different cases, and we have to count how many we have on each case, then we add all of them up. Right, that's what we have. The remaining of the section we have the proof. I just leave you that part is to prove that why do we have something like this. The combination of select R is the same as the number of combination of select N minus R. This is the same thing as we say we select 5 cards, or we select 47 cards out of 52, still the same way. Right, I said I'll leave the proof here for you to read, but I will stop this section here. As always, thank you for watching and see you in another video in this week math.